Hello guys, today we're going to be adding exponents. Here we have the equation 12x to the fourth power plus 3x squared minus 5x minus 2 plus 15x squared minus 10 plus 9. So what do you do when you're adding exponents? When you're adding exponents, you're combining like terms. Using this, we're going to find the terms that are alike in this equation. As you can see here, I have drawn a line under the ones that are alike. Now I'm just going to combine these terms. After combining the like terms, I got 18x squared minus 15x plus 7. But wait a minute, we're not done, since we have the 12x to the fourth power. What do we do with that? Well, since you can't combine it with anything else, all you have to do is just bring it down to the equation. Our new equation will be 12x to the fourth power plus 18x squared minus 15x plus 7. Now that we have done this, remember, adding exponents is just combining like terms. If you don't have a term that can combine with anything else, you're just going to bring it down. Hello guys, today I'm going to be teaching you how to subtract exponents. So when you're subtracting exponents, what you're going to do is take the sign from the amount you're taking off and switch it around. So using this equation, 2x to the third power plus 4x squared minus 1 minus negative 5x to the third power plus 7. Well, I'm going to be taking the sign of the negative 5x to the third power and switching it to positive 5x to the third power, and taking the sign from the positive 7, I'm going to take it to negative 7. So my equation should look like this. Now that I've rearranged my equation to an addition, because what you're doing when subtracting is just switching around the signs. See? So when you do that, after you do that, you're just going to combine the like terms. So your equation should be 7x to the third power plus 4x squared minus 8. So remember, when subtracting exponents, you're going to change the sign of the amount you're subtracting of to the opposite in order to combine the like terms. Hello guys, today I'm going to teach you how to multiply exponents. So when multiplying exponents, you can do it in different ways. You can distribute and such, but I like doing the box method. With the box method, you're just going to write your equation, which in this case it's 12x minus 2 times 5x plus 25. So I'm going to write the 12x minus 2 horizontally and the 5x plus 25 vertically. And now I'm just going to cross multiply. So as you can see right now, I have done that. But before we go any further, I just want to state that when multiplying, you're going to add an exponents together. So what I mean is, when you're multiplying, you're going to add this together. So like 12x times 5x, well, you're going to equal 6, you get 60. But you have to add these two together. So it's going to be 60x squared instead of just 60x. Now, all you do after you multiply them, you added any exponents that needed to be added together, you're just going to combine terms. So combine the like terms, so 300x minus 10x, and I'm just going to leave the 60x squared and the negative 50 alone. My equation should be 60x squared plus 290x minus 50. Now let's remember, when multiplying exponents, you're just going to multiply them normally. Add any exponents that need to be combined together, and then you're just going to combine the like terms and bring anything down that doesn't have anything to combine with.
And the first thing you do when you get a problem like this is to see who is the problem child. And the problem child is the one you cannot simplify. And this right here, you cannot simplify the 5. So what you do is simplify the 9, the 3, and you keep the 5. And what you would do is multiply it by the problem child. And what you would do right here is keep 3 on the outside and 5 on the inside. And since 5 times 5 is 25, you do that. And then you simplify it, the bottom one, which would be 5. And then carry that one over so you can't simplify that one. Now, to see if you're right, is you need to check if there's a radical. And if there is, you're wrong. And if there isn't, you might be right. You have to check all these first. Okay. And another one is you can't simplify the fraction. If you simplify the fraction, again, you might be wrong. And number 3, you can't simplify the top one or the bottom that has this symbol.
Hey guys, today I'm going to teach you how to exemplify exponents. So right here I have my equation. It is the square root of 48x to the third power. So when you're simplifying exponents, you're going to factor them until you find the prime numbers. Here I found the prime numbers, but I also found two pairs actually. So when you find the pairs, when you find two of the same number, that will be a pair. And here I put 2 because a pair will equal just that number. So a pair of 2's equals just 2. And here I circled the 3 because it was the prime number. It was lonely. There's no other prime that is 3. Here I did the same thing, found a pair. And that x right there is just lonely, but it's the prime, so I'll have to keep it. Now I'm gonna rewrite this, and what I get is 4x, the square root of 3x. The reason I got 4 is because I just multiply these two together. And again, they're not 2 times 2 times 2 times 2. You don't multiply 2 4 times, no. It's a pair. A pair equals 1, 2. So you just multiply 2 times 2 and get 4. See, x, bring it down, just x. That's the pairs you find are going to go outside, while the primes you still have are going to inside. So here it is. When simplifying, you're just going to factor what's inside the house, find only pairs, and bring them outside and keep the others in. This is how you simplify. Thank you very much for watching.
Okay, so today I'm going to show you how to change a radical into its original form. Alright, so first you need to see if there's a number in the index. And in this example, there isn't a number in the index. So what you would do is that in every index, if there isn't one, a number, it's automatically divisible too. So the index always goes on top. Now, the x, the number in the square root is always the base. And so you see right here, it's the base. And the 3 is always the bottom number. And that's how you simplify it.
Hello guys, today I'm going to explain the properties of rational and irrational numbers. What I'm going to explain is the reason why the sum or product of a rational and irrational is rational, or the sum or product of an irrational number and an irrational number is irrational. The reason why the product or sum would be the same as what you're multiplying or adding by is because you're doing it by the same thing. You're not changing it. You're not multiplying by a rational times an irrational. It's just rational and rational, or irrational and irrational. You're not changing that. You're not changing its form. It's the same thing. So your answer should be the same thing. But let's just say you multiply it or add it by rational and irrational. Well, you're going to get an irrational number. The reason how I found this is because I multiplied 1 times pi, and I got pi. Pi is an irrational number. So it only makes sense that anything you multiply irrational times an irrational by, or add an irrational plus an irrational, it will always be irrational.